Hello everyone, and welcome back to the Introduction to Python course. In this chapter, chapter 9, we're going to be talking about dictionaries and sets. So specifically, we're going to be talking about, well, dictionaries, sets, and also what it means to serialize and deserialize objects, which comes in very handy when working with large data sets. All right, so we've talked about at this point in the actual class, we've talked about lists, we've talked about strings and how strings are just a different type of sequence. So we've talked about different ways of actually organizing data. Well, dictionaries is just another way that we can actually store that data. Specifically, unlike lists, which are stored and the index is what determines which item we're looking at in a list, in a dictionary, they consist of keys and values. So what that means is each key has a specific value associated with it. So instead of saying, oh, I want to go to this index in this list, now you're saying, oh, I want to go find the value of this key in this dictionary. Okay, it's a type of mapping. This type of mapping is very useful. So instead of having to search for an index and not understanding what the index actually means, we now have a human readable key that we can then use to actually specify what value we want to return. So for example, right here, if we have a dictionary, let's say we have one where we have stored, let's say, names and their ages. If I say dictionary, which is that dictionary, of that key, and that key might be that person's name, then that will return back the value associated with that key, which would be that person's age. Now, it's important to know that if a key is not in a dictionary, if it is in the dictionary, the associated value is returned. If it's not in the dictionary, you have a key error exception that's raised. So to prevent any kind of key error exceptions, we can either use try except statements, or we can check by using the in and not in operators first. So we can say, hey, is this key in this dictionary? So for example, right here, like we said, we have our ages dictionary. Again, the dictionary is created with those curly braces you see at the beginning and end. In this case, we have each name. So in this case, we have Jim, who's 29, Jill, who's 35, and Zhao, that's 21. So with each of those different names, they're associated with a different age. So if we want to get, say, Jim's age, we can do ages, bracket, like we would do a list, but instead of putting an index in there, we're going to put that string key, which is Jim. That string key will look in the dictionary, find out where Jim is, and return the associated value that's associated with Jim, which is 29. The same thing goes for Jill. Here, it's going to go in. If you see where Jill is, right here, where we have the actual string, it's going to go in here. Is Jill the same as Jim? No, so we don't care about that value. Is Jill the same thing as Jill? Yes, Jill is the same thing as Jill. That's what we mean by the exact same. So therefore, now we actually care about the value 35. So we're going to return back that value so we can say Jill's age is 35. Now, we put this in a try except because if any one of these is incorrect, so if Jim is not in there, it'll stop and say key not found. Now, it's important to note that if Jim is not found, it also will not print Jill and Zhao because remember, try excepts go until there is an error. It does not do anything after the error. Instead, it stops where it's at and goes down to the except statement. So in this case, since all three of them are there, it'll print out Jim's age 29, Jill's age 35, and Zhao's age 21. Now, when we're actually working with dictionaries, unlike, let's say, a tuple that's immutable, dictionaries are mutable. So they're more like lists than they are, say, strings or tuples. So a dictionary, you can actually add new key value pairs. So if you do dictionary, whatever your dictionary is, in this case, like say we said before, like age, we could do age and then bracket somebody else's name equals their age. If that key is already in the dictionary, it just updates the value that's associated with it. If it's not found, that key value pair is added. Now, that's how we add keys to add and update key value pairs. If we want to delete a key value pair, we just use the del keyword that we've talked about with lists before. And we just do delete dictionary bracket key. That means that, and then in that case, if the key is in there, the associated value and key is deleted. If it's not found in the dictionary, a key error exception is raised. So again, make sure you're using try excepts, make sure you're using the in and not in operators, just to make sure that you're not causing any kind of unnecessary errors in your program. So again, here's an example. Let's say we want to update, so everybody gets a little bit older each year. So let's say Jim, it was his birthday, we're going to update it. So now we're saying Jim is now equal to 30. Okay, so now in that dictionary, Jim's key, the keyword Jim, will now be associated with the number 30 instead of 29. Similarly, let's say we have somebody new. Let's say her name is Jane. So Jane's age is 25. So by doing ages of Jane equals 25, now what we're doing is we're saying, no, we don't have Jane in there. So we're going to add Jane, and we're going to associate that key Jane with the number 25. All right, so let's say this is let's say this is just ages of club members or whatever, or customers. And let's say Jill decides that she wants to stop being a club member or customer. So what we're going to do is we're going to go ahead and delete ages of Jill. Okay. If Jill was not already in there, then this would throw an error. But because she is in there, it's going to remove the value 35 and the name Jill completely. And then we'll just have Jim, Zhao, and Jane left. However, if Jill was not in this dictionary to begin with, the except statement will go off and say cannot delete key. All right, so just like with lists, and this is the reason we start with lists, is because a lot of the stuff you learn with lists can apply to other things. For example, the length function, if you take the length of a dictionary, returns the number of dictionary elements. Now, this is not the number of keys and values, it's just the number of entries. So each key value pair makes up one entry. So if I go back over here, I have Jim, Jill, and Zhao. If I do the length of that, it's going to give me 3. It's not going to give me 6, it's going to give me 3. So that's how you can actually get the length, the number of entries in a dictionary. Now, keys must be immutable objects, but the associated values can be of any type. So what that immutable object means is the key can be a number, the key can be a string. It has to be something that's immutable, something that's not going to change. So one dictionary can include keys of different immutable types, and values stored in a single dictionary can also can be also of different types. So what this really means is if you have, let's say, a dictionary of names or IDs or something like that, as long as they're immutable, it's fine. But the values can also be different as well. There's a lot of flexibility in Python, and you'll see that as you start to work with dictionaries as well. All right, so just like before, we talked about this a second ago, when you want to create an empty dictionary, you just use the curly braces. If you would rather, you can also use a built-in function called dict with the 2 parentheses afterwards. Do not get those mixed up. Again, the parentheses go with the dict function. If you're going to use an empty dictionary by itself, just use the curly braces. And then just like with lists where we can append stuff, we can also add items to the dictionary as the program executes. Similarly, we can also use for loops to iterate over the dictionary as well. So we can do for key in dictionary, and then I'll go through and iterate over each of the different keys in the dictionary. So right here, if I say for I in range, it'll say for I in range of 100. We obviously know what that does. We have a range function, goes from 0 to 99. And I'm going to create new key value pairs where every index or every key in this dictionary, every key is associated with the square of its value, which is stored as the value. So if I want to print those all out, I can do for key in squares. I can print squares of key, just like that. Okay, so now let's say you want to completely clean out your dictionary and you're done with it and you want to go back to the basics, empty dictionary. You can do that by just doing dictionary.clear. So again, whatever your dictionary name is, if it's like mydict, if it's ages, you can do ages.clear, mydict.clear, whatever it is, .clear. You also have your .get method. The .get method will get a value associated with the specified key. This is the power of a dictionary. Instead of, and we talked about this before, using the brackets where you can say, hey, give me Jim. Well, the brackets causes you to raise a key error because Jim doesn't exist in that dictionary. However, if you use the .get method, you can say get Jim, comma, default. Default is just what you want the value to be if you can't find Jim. So instead of raising an exception, it just says, hey, we can't find Jim, so let's say his age is -1 because -1 would assume that he's not in the actual dictionary. Okay? All right, similarly, we can also do .items. .items will return all keys and associated values. So it actually what it does is it returns as a dictionary view. With each element in the dictionary view is a tuple that contains a key and value. So basically imagine you have this long list of keys and value pairs with each of the key and values being a tuple. And you can use a for loop to iterate over the tuples in the sequence to actually look at each of the different keys and values. So example here, if I said something like, here's our favorite foods, we have one is nachos, two is steak, three is salmon, and I say 5 equals favfood.get5. If it's undefined, which in this case it is because we don't have 5 favorite foods, then for item in favorite foods dot items, we're going to print it out. And it's going to print out 1 nacho, 2 steak, 3 salmon. It's going to go through and say, hey, I don't know where you got 5, but we're going to print all the ones out. If we did happen to have 5 favorite foods, it would just print out our 5th favorite food. Then at the very end, if we want to clear the favorite foods, we just do favfoods.clear, just like that. All right, now let's say instead of getting dot items, because you don't want both the keys and values, you want to do just the keys or just the values. If you want just the keys, it returns, if you do whatever your dictionary is, dot keys, it will return a sequence of keys that you can iterate over. And you also have values, you can do dot values. Similarly, it will return a sequence of dictionary values. This means that these keys and these values will not be associated anymore. So what that means is if you do dot keys, it gives you a list of keys. Those keys are not going to have the values with them. You'll have to go back to the original dictionary to figure out what value is associated with each key. Same thing with values. If you go into dot values, and use the dot values method, that'll give you a list of values, but you won't know what key each value is associated with. So just be careful with that. But if you just want let's say you have the ages like we talked about before, you have all the names and the ages. If you want to just get the ages and you want to do some kind of statistics on it, like getting an average age, you can do dot values because it doesn't matter who the age belongs to. If you want to get a list of all the names that are actually associated with the actual, let's say, membership, customers, whatever you want to call it, the list of ages we have, or the dictionary of ages we have, then you can do dot keys, and this will return all of the different names in our dictionary because those are all the different keys in the dictionary. So here you go. Here's an example of that right there. You have ages equals Jim, Jill, and Zhao. If I just want the names, I can do ages.keys, and I can print each one of those out. And if I want just the ages, I can do ages.value as well and print out just the ages. Again, the keys, when I do ages.keys, I do not know what actual age is associated with each name now. I'd have to go back to the dictionary to find that out. Same thing with the values. If I do ages.values, I have no clue whose name is associated with each of these values. I'd have to go back to the dictionary and go through and figure out which one that actual name is associated with that value. Okay. So not only can we add stuff and delete stuff, we can also pop and pop item. So what pop does is it's going to return the value associated with a specific key and removes the key value pair from a dictionary. So we'll see this later on as well as we go. But an example would be maybe let's say we have a dictionary of raffle tickets. If we have a dictionary of raffle tickets and we want to give somebody a raffle ticket, then maybe we don't want to have that in our dictionary afterwards because we don't want to give it to somebody else. Similarly, maybe we have a deck of cards. You take a card out of the deck. Is that card still in the deck? It's not. It's out of the deck now. It's somewhere else. It's not in the deck anymore. So maybe you want to pop that item out. So you say, hey, I want to pop this card out. I want to pop this raffle ticket out. And whatever the value is associated with that, that is returned back from the dot pop method. Now, if you do dot pop item, it's a little bit different because dot pop item has two different approaches. Before Python 3.7, which is the more recent version of Python, it randomly pops a key value pair. However, this is important to understand which Python version you're using. After Python 3.7 and to this day, it pops the last key value pair inserted. That's because of a large difference that they made in Python 3.7 and the update. So keep that in mind. If you're using Python 3.5, Python 3.1, Python 3.2, it's going to do a random pop. It's not going to be the last one. If you're going to do something like, let's say, if you're using Python 3.7, 3.8, whatever we're on now, then when you pop, it'll be the last key value pair. So make sure you understand that when you're using .pop item, because it may give you back some, let's say, undeclared or unthought of behavior, and it could mess up your program. Okay? All right, so here's an example. If we do .pop It'll give us 1. That'll give us right here, we have .pop. Again, keep in mind pop also has a default, which basically means if we can't find it, it returns the default instead. So over here we say .pop1. We say first user added. The number 1 should be the key. That's going to be Jim. If we pop Jim and then try to pop Jim again with the number 1, it'll say first user added would be Jim. First user added the set. Next time we do it would be error because 1 is no longer there because we popped 1 out. We'd have to change this number right here to 2. So it'd be .pop2 for it to go to the next person. All right, last user added. Depending on which version of Python you're using, if you're using a more recent version, you can do names.popItem. We do bracket 1. Why do we do bracket 1? Because again, this returns a tuple. So we know that the name is right here, okay, and the value. So the value would be 0 and the name would be 1. So when we do .pop, we get the tuple of 5:Chris. We want the Chris name part, so we'll do bracket 1, and it'll say last user added is Chris. Okay, in earlier versions of Python, it's not going to be the last user added. It's going to be a random user. Okay, just keep that in mind. All right, so let's go through this checkpoint here. So if I were to ask you, what are the 2 parts of a dictionary called and which are immutable? So what comprises a dictionary? So if you look down the line, you can actually see there's a hint there. And the answer would be the keys and values. So remember that the keys are immutable. You cannot change a key, but you can change the values that are associated with such keys. The values are mutable, the keys are immutable. So how can you define if a key value pair exists in a dictionary? Or determine if a key value pair exists in a dictionary? So how can we do it? There's 2 different ways we can go about it. We can use the .get method, and if we do that, if it exists, the value is returned, otherwise default is returned. And the other way is we can use the bracket notation. But keep in mind, if you do that way, you will need to use try excepts, otherwise it will cause an error. So what does the .items method return? So if I asked you that question, you could answer, it returns all keys and value pairs. If I ask you, what is the difference between .pop and .popItem? You could then answer, the pop method pops a specific key, and popItem pops the last added key value pair. Again, keep in mind, popItem, the behavior depends on your version of Python. So before 3.7, it pops a random one. After 3.7 and beyond, it's going to pop the last one. All right, so what will the following code display here? So if I have stuff, and that stuff is my dictionary, and I have 1, the key 1 is associated with AAA, 2 is associated with BBB, and 3 is associated with CCC. If I do 4K in stuff, what is it going to print? So think about it for a second. All right, so if you said that it would print 1, 2, 3, you would be correct. Because remember, when you do 4K in stuff, it's going to give you the keys in stuff. If you want the value, you have to do stuff bracket K. Okay? All right, so let's try this one together. So on D2L, we've used this file before. There's a file called worldserieswinners.txt, which contains a chronological list of World Series winners. We're going to go ahead and write a program that reads this file and creates a dictionary in which the keys are the names of the teams, and each key's associated value is the number of times the team has won the World Series. So basically, we're going through and we're making it and saying, okay, look, the New York Giants have won 5 times. And we're going to have that value associated with the string New York Giants. The program should also create a dictionary in which the keys are the years. So we're making 2 dictionaries. And each key's associated value is the name of the team that won that year. So then on the second one, we're going to have a list of years. So we're going to have, 19, in this case, it'll be 1903 to 2009. And each of those keys should be associated with just the team name that won that year. Following that, we should then prompt the user for a year in the range of 1903 to 2009. And we should then go ahead and display the name of the team that won the World Series that year and the number of times that team has won. So we're going to need to use 2 lists, or 2 dictionaries, excuse me. All right, so let's go ahead and give this a shot. So what we're going to do first is we're going to go ahead and create our Python file. So I've already done that over here. We'll go ahead and go over here to 9.7. And here we have our basic Python program approach. So if I do, make it a little bit bigger. All right. So the first thing we're going to want to do is we're going to want to go ahead and create our dictionaries. So we're going to go ahead and create our win count dictionary. And here we're going to say win count equals, and then for an empty dictionary, we can do curly braces. The second dictionary we're going to do is we're going to create our year winner dictionary. And this one, I'll go ahead and just use the other way. You can use the other way as well, but I'll just do dict with the parentheses. Both of these make an empty dictionary. All right, so now what we're going to want to do is we're going to want to set the year counter to the first year. So we know that year, we'll say current year equals 1903. Okay, that's what we said back here in the problem, where it ranges from 1903 to 2009. Now, what we're going to want to do is we're going to actually want to open this file that we have. So we have worldseries.txt. That's what the file looks like. It's just all the different winners. This up here is 1903 and 1904. We're going to have to deal with this as well, where it says World Series not played in 1904. So we'll have to deal with that one as well. And then same thing down here in 1994. It was not played either. All right, so what we're going to want to do is we're going to actually want to do some file validation too. So what we're going to do is we're going to do our file validation, because if it's not there, we don't want it to break our program. So we'll say validation. There we go. And we'll use a try. We'll have except here. So if there's any errors, we'll go ahead and print error file not found. And we'll say quitting. So if I can't find the file you're working with, I'm just going to go ahead and quit. So we're going to need to work with that file. So there's a couple different ways you can use files. I'm going to show you both ways in this video, but the first one I want to show you is we're going to open the World Series file. And we're going to do it by doing with open worldseries.txt with the R flag for read as FP. So this is the first way. If you use the with approach to using files, you do not need to close it, because after we get out of this indentation, it will close the file automatically for you. So then while we're in this file, and while we have the file open, we're going to read each line of the file into our dictionary. Okay. Now remember, we have two different dictionaries, so we're going to have to do two different steps for each line of this file. So we're going to say for line in fp.read lines. So we've gone through, read each of the lines. The first thing we're going to want to do is we're going to want to work with this actual year winner dictionary. It's the easier one, so we'll do year winner dictionary calculations. It's just nice and organized here. We'll just put a little bit of dashes here to make it very, very clear what we're doing. A little header there for this code. And then we're going to come down here and we'll say years. That's our dictionary. Bracket the current year we're on. We know that the first one we enter in up here, this is going to be 1903, then 1904, and so on. So for the years, this is our dictionary with a key of 1903, which is the first year we have. That's going to be equal to whatever the current line is, dot strip. We'll get rid of the white space. So what it's going to do is it's going to give us Boston Americans, and it's going to say 1903 with the years. The key for in this year's dictionary is 1903, and the value is going to be Boston Americans. Okay? So if we do that, we then also need to make sure we increment the current year as well. So we go to the next year as well. So we'll do current year plus equals 1. And if we do that, let's just go ahead and work on this part first. And at the end, if we go ahead and print years, just like that, we'll see what it gives us back. So let's go ahead and run this. So now down here, you can see we have 1903 is Boston Americans. 1904, we have World Series not played. 1905, we have the New York Giants. 1906 is the Chicago White Sox. 1907 is the Chicago Cubs. And this makes sense because this follows the same trend and the same approach as this here. Each year we put in is going to be, each team we put in is going to be associated with the next year in the list. So we have 1903. That's 1903 up here. Then we increment that down here for current year. we pull in the next string, the next line, which is World Series not played in 1904. That's associated with 1904. Okay. If we go all the way down to 1994, keep going, keep going. We'll see right here, 1994. Oop, what happened there? Why did we miss one? Why is 1993 World Series not played in 1994? That's a good question. Let's see. So over here we have 1903, 1904, 1905. Is there a step missing? Do we miss a team? That's a good question. So the idea here is that we should have everything right, and there might be a team actually missing from the file here. Because if we go all the way over here, we have 1992, and then we have 1994. We go all the way down, we have 2008, just like that. So this problem said it went to 2009. So why are we stopping early? It looks like a team was missing from this actual list. So we won't worry about that right now, but just keep that in mind that we take that sanity check that we've gone through every line in this file. We've gone through all of these different lines. We have 1 down to 106, so we have 105 teams. We do that math. Hold on 1 second. If we come back over here, if we do 1903 plus 106, we have 2009, but there is one team missing, which is not going to be a cause of concern for us. But from this first part here, you can see we do have that sanity check correct. We have our year followed by the team, the year followed by the team, all the way down. And even though we are missing a team over here, it should be the year followed by the team. This should be shifted over. That's okay. Just keep in mind that, again, sometimes the data you get will have errors in it. Okay, so the first part is we know that we're doing it correctly because we have our year and our team, our year and our team. Just because they missed a team does not mean it's going to throw everything out. If you want to, you can go ahead and just take your favorite team and just make sure it's before row 91 here. And we can just copy one. So we'll just do something like, we'll have the LA Dodgers win a second time, shift everything down. Doesn't have to be exact. But if we run this now, we go over to 1994, you'll see now 1994 is correct. Right, go over a little bit here. Here. So that was just one team was missing from the actual file. Okay. All right. So with that being said, we now have all of the different years in place. We have all the different wins. Again, we just added one extra team because of that offset. Make sure that you add a team before row 91. It can be anywhere. Just add one at the top up here and you'll be fine. Make sure it's below 1904 here. And if you're going to add one at all, make sure it's below that and before that in between there. Okay, so now that we actually have our actual years correct, the next step is we actually need to add our win count as well. So we'll do win count dictionary calculations. Okay, we can do this at the exact same area because we're going to, for each line, we're going to go ahead and count them as well, and we're going to count them while we're also putting them in the years dictionary here. So what we need to do is we need to say if the team is already in the dictionary, increment wins value by 1. So we're going to say if line.strip, that's the team that we're looking at, that's the line we're currently looking at, in winCount.keys. So we're saying if it's in the keys already, then we want to do winCount of line.strip plus equals 1. So we're saying, hey, look, is that team in there? It is. So we're going to add 1. Then we could say if the team is not in the dictionary, we will then add to the dictionary and with a value of 1. So we'll say else, and then what we'll do is we'll do win count. Clicked on the wrong thing. We'll do win count of line dot strip equals 1. Okay, so if we run this now, let's go ahead, we print our years down here, so let's go ahead and now we'll try this. We'll go ahead and print the win count library, or the win count dictionary that we have. We'll go ahead and run that. So now we'll see down here we have Boston Americans 1, New York Giants 5, Chicago Cubs 2. So if we can check this by just going in here and double clicking or selecting New York Giants and do Control F. And you'll see right here we have a number 5 for 5 times. So it's 1, 2, 3, 4, 5, and then come back to the top. So we are doing that correctly. However, we don't really want to say a team name of World Series not played in 1904 is 1. So what we can do is we can use string comparisons to check and remove placeholders from when the World Series wasn't played. So what that means is we're going to come down here and we'll say if, and look how this says, is World Series not played, World Series not, just like that, like this, that first part. In, it says if it's not in line.strip, then we'll go ahead and add it to the dictionary. Okay? So the reason we're doing that is because we don't want to add this one, and we do not want to add, where's it at? This one right here. We don't want to add those World Series not played, because again, that's not a team. Why would we want that? All right. So if we go ahead and run this now with the printing the win counts, you'll see now we do not have the World Series not played there anymore. It's been taken out because it's not an actual team. Okay, so now that we have that, the next step is, if we come back over here, is it should prompt the user for a year in the range of 1903 to 2009 and display the name of the team that won the World Series that year and the number of times that team has won. So what we're going to do is we'll come down here. We don't need win count anymore. So get rid of that. Just the print statements. We still need the actual dictionary. And we're going to go ahead and do some input validation. So we'll do input validation loop. We'll say while true, try, except, we'll get to that in a second. But inside this try, we're going to do user year equals int of input. And we'll say enter a year between 1903 and 2009 to check. Okay. Then we can say if user year is greater than or equal to 1903 and user year is less than or equal to 2009, then we'll go ahead and break out of this loop. So again, we're getting that user input, so we can put a comment here for ourselves. So we can say get user input for a World Series year. And then we can come down here and we say break out of the input validation while loop when we get valid input, just like that. All right, if we don't get valid input, or if there's an error in the actual input, then we want to print error invalid user input. I can put another comment here for ourselves just to help us understand what was going on. If invalid input, print error message, and try again. All right, so we have to do that here as well. We can say else, we can print, and we'll just take the exact same message actually here. And if it's invalid, we'll just do that again. Okay, so what this means now is if I run this now, and I come in here, and I try to put in, let's say the team, the year I want to check is A. That's invalid. If I check the year 0, that's also invalid. I have to do a year between, if I do 1902, that's also invalid. If I do 2010, that's invalid. Once I do 1903, we're going to go ahead and keep going. And then in this case, since we don't have anything else after that, we're just going to go ahead and finish. All right, so now that we have our input validation correct, we can go ahead and do our year validation. Okay, so what that means is we have a try except, and we will need this here in a second. That'll make sense in a second. We're going to go ahead and print the team that won that year. Okay, so we'll say print, let's say curly brace, winning team, curly brace, dot format. And we'll say the user year. So we'll say the 1903 winning team is going to be years of the user year. So what that means is we're saying this is the year you entered. So let's say it's 1903. We're saying 1903 winning team, and we say years of that key value of that year you gave us is going to be whatever's here. And in that case, it's going to give us the first one in the list. If we do 1903, it's going to be Boston Americans. Okay, so we print that out. Then we're going to also go ahead and print the number of times that team won if a team won that year. Okay, keep in mind, remember, we have 2 years that didn't actually have teams that won. So it says we have to ask ourselves the question, if World Series not is not in, just like we did before, years of the user year. So if that year is not, that actually has a team that won, then we're going to print the whatever team it is have won blah times. We do format here. And in this case, we're going to say years of user year, which again is going to be the team that won that year. And then we're going to have win count of years of user year. Remember, we want the team that won. So years of user year, this one right here, this dictionary value that's coming back from this, accessing it using this key, is going to give us the actual team. And then when we pass that team to win count, we get an actual count that won. All right, so why do we have this try except here? Because if we did not have this try except here, if we do print error, World Series year information not found. Okay, so if we don't have this here, and let's say you forget this part right here. Let's say you change this to 1900, okay? And if we run this now, and let's say we have 1900, we don't have any information on the year 1900. Okay, so let's say it's 1903, okay? And let's say we had that problem we had before where the LA Dodgers didn't actually win a second time. Everything's off shifted by 1, and you think you got the data correctly. But then I say, give me 2009. Well, this part up here was right. We said we were between 1903 and 2009. We should have data for 1903 to 2009. But because we are off shifted by 1, because we're missing a team somewhere in here, that is going to lead us to not having actual information for 2009. So what that means is if I come over here and I actually print years, like we did before, I run this, let's say it was just 2009. If I go all the way to the end of this to where 2009 should be at, you'll see that because we're missing 1, we don't actually have an entry for 2009. We should. This says between range of 1903 through means including 2009. So whenever you're working with large amounts of data, keep that in mind because you will run into issues where you should have the data, but the data is not there, which will cause your program to crash. Even though it's not your fault, the data you brought in does not have the correct range. Okay, so this try except will solve that problem for us, even with this check here. And in case we ever get less data than we should, that'll solve that issue. Okay, so again, just going through this, we made our dictionaries. You can use either one of these ways or both. It doesn't really matter. You can use the curly braces or the dict command here. Then after that, we set our current year. We use this down below. We use file validation just because if the file does not exist. So again, if I change this to World Series 1 and try to run it, it'll give me error file not found quitting because that file does not exist. That's usually a really good idea to do. So with the right file selected, we're going to go in here. We're going to go ahead and read it. We say with open this as FP. When you use with like that, it says, hey, while we're in this indentation with the with command, it's going to use FP in this after we get out. So after we get out of this actual accept command down here, FP will be closed automatically. So then we're going to come down here. We'll say read each line. So we're going through each line, and we're going to go ahead and add each year's winner to the years list and increment the current year by 1. So that means the first time we go through the years with the key, so in the dictionary years with the key 1903 is going to be equal to whatever team we currently have. We'll increment the current year value to 1904, then we'll go around again, and whatever the next team is we'll have is going to be in that year's list as well. Moving on, we'll then come down here to win count. We'll check right here again, line.strip is the team we're currently looking at. If that's in the keys already, we want to just increment the value. If it's not, and a team actually won that year, so it's not the World Series was not played lines, then we want to go ahead and actually add that to the actual dictionary with whatever team it was, followed by one win, because by being in the list, that means they've won at least one time. Okay, so once we have those all in the dictionaries, we have two dictionaries now. We come down here, we get the user input. If the user input is in the valid range, we go ahead and break out of our input validation loop. If it's not, or if there's an error with the input, then we say error invalid user input, and they have to do it again. Come down here to year validation. We have this try except here again, because even if we got the data, we might not have gotten all the data. And if that's the case, we don't want our program to crash. So then we give whatever year they gave us, we go ahead and put it in. We say whatever year they wanted. So let's say they put in 1903. We go to the years dictionary, find the key 1903, and return the value for that. And that'll give us the years and the winning team's name for that year. Then if it's a year that somebody actually won, so it's not this, if it's a year that somebody actually won, then we'll say the, and whatever that team was right here, remember this returns the team name, has, or the blah teams have won. Then we go to our win count using that team name we got right here to figure out how many times they've won. Okay. So with that being said, we now have used two different dictionaries in this right here alone. And now we can see how we can add to it right here. We can also pull back from it down here. Okay. So now that we have a good understanding about that, I want you guys to go ahead and try this one on your own. So I want you guys to write a program that reads the contents of a text file. Specifically, I want you guys to use the good old text.txt from the previous chapter, the Henry VIII one. And the program should create a dictionary with the key value pairs that are described as follows. Specifically, I want you to write a program that will have the keys be the individual words in the file, and the values be the number of times that word was found in the file. So you're going to go through, iterate through. Once you figure out where they're at, I want you to go through and add each of the different times that word was actually found in the file and increment that up just like we did the World Series winners. Once the dictionary is built, though, I want you to create another text file and write the contents out alphabetically. So basically what you have is if you have the word A should come first, the keys of A should come first, and so on and so on. Okay? So go ahead and try that on your own. And once you've given that a shot, we'll go back over it together. All right, did you give that a shot on your own? If you did, what I'd like to do now is we'll just go ahead and go over it together. So we'll go ahead and open up 9-10 here. We have an empty page here again. And what we're going to do is we're going to go ahead and create our dictionary just like we did before. So in this case, we got a word count going on. So we'll say create word count dictionary. Okay. We'll have word count equals an empty dictionary just like that. And then we're going to go ahead and get the text file to read from user input. So we'll say file equals input. We'll say enter the text file's name that you want to process. Go ahead and zoom out here a little bit so we can see the entire thing again. Bring this over a little bit. Okay. So we're saying just give us the text file. And then just like before, we'll have our file validation, because again, we want to make sure we actually have the file. Do try. We'll do accept. And then from here, we're going to do open the file. So we'll do open the file. So we'll do fp equals open. We'll do file r. So that's we're reading the file in. And then we're going to read all text from the file and split on white space. Because again, we care about the count of the words, not exactly where they are at. So we're going to do words equals fp.read, and we'll go ahead and do dot upper as well here, just because we can, and we'll do dot split. So that gives us all the uppercase words in this file. So then we can go ahead and close the file. We'll do fp.close. Now note here, in the previous example, we used the with clause up here, so we didn't have to close the file. If you do it with fp equals open, you do need to use the dot close command. Okay? So after that, we're going to go ahead and iterate through all the words and count them. Okay? So we'll say for word in words. We have our actual list of words here. We're going to go ahead and we can actually print word just to see what we're looking at. We run this. Oop. Forgot to actually put the print statement down here. So we'll print. We'll say error file not found. We'll say quitting. We'll go ahead and return right there. Okay. So if we run this ourselves, we do text.txt, we have all of these different words here. Okay, so we have I'm Henry the 8th, I am, there's all the different words we have. So if we go ahead and we say, if, just like we did before, we're going to say, let's go ahead and put this here first, if the word is already in the dictionary, increment value by 1. So we'll say if word.upper, which we already have upper, so we don't actually need it there. So we'll do word.strip, just to make sure we don't have any white space, in word count.keys. Then we'll do word count of word.strip, strip plus equals 1. So if it's in there. Then we can say if the word is not in the dictionary, add to dictionary with a value of 1. Okay, so we're doing there. Zoom out just a little bit more here again. Make sure everything's on the same page. All right, so if it's not in there, we're going to go ahead and do else. And we'll do word count of word dot strip equals 1. Okay, so after this, we now have our dictionary of words. We should also have our counts here. So if I come down here, let's go ahead and zoom out just a little bit more. A little too much there. We'll bring it here. And we'll go ahead and do print words or word count. Okay. So if I run that now, do text.txt. And we have I'm right down here. Zoom this up a little bit. I'm Henry the 8th. I am. Now the only issue we're seeing is, look at this right here. We have am with an exclamation point and am with a comma. So we're counting words. We're not counting. We want to get an accurate count, so we don't want this punctuation. So now if you look around the internet, there's plenty of different ways to actually clear out the punctuation. But one of the easiest ways to do it is to use regular expressions. So I'm going to give this one to you so you don't have to worry too much about it, but you should understand regular expressions, and you should start to dabble with them now. You may not understand them immediately, but you should start to dabble with them. So we're going to go ahead and remove all white space, which is going to be the \s command within regular expressions, and special characters, which will be the \w command. Now, this is notes. This does not catch underscores. However, this is something that I'm okay with, so I can just leave it alone. And I'll say clean word equals, and when we're using regular expressions, we can use regular expression dot substitute, which is sub. We'll give it the pattern we want to look for. So we'll do the R for regular expression string, quote, bracket, and we're going to do the caret symbol, which means one of. We'll do \w, \s, So it's basically saying, given, actually we should change this to this command here, I think it is. No, it should be, let's see, that should be fine actually. So what we're going to want to do is we actually want to grab the standard apostrophe here. We're going to put this one here, this one here. Okay, so after we do re.sub, we have \w, which means look for any occurrences of special characters and or white spaces, and we're going to replace them with nothing. Because we want to go through and replace them with nothing, so we have this all fully cleaned up. So that's now going to say, we're going to look for, and again, look one line for this one, but for now this is going to say, find all the different white space and all the different new line characters that we find, any occurrences of 0 or more of them, and replace them with nothing. Okay? Again, the \w here only does not catch underscore characters. It catches every other type of punctuation, which again, I'm okay with. I don't need to worry too much about underscores, so we won't have to worry about that. All right, so now we have clean word. We're going to go ahead and change out everywhere we see word with clean word. Like that. Come down here, do clean word like that. And if we go ahead and run this now, do text, come down here in the actual input box, text.txt. We got to make sure we actually print it too. So let's come down here, we'll do print word count. Try that one more time. Do text.txt. And now you see we have only one word am, only one word I, we have I'm, the, to, and we have less words, but they're all clean words because we've taken out all punctuation. Okay, so once we've done that, we now have a word count, but we need to be able to write them out to a new file. So we're going to go ahead and write the results back out to another text file in alphabetical order. Okay. Now one of the cool things is we can do fp equals open, and we'll just call this the sorted word count.txt with the right flag with W. Then we can do for key in sorted, which is a function we can use when a dictionary, word count. So if you look at sorted here, this function right here returns a new list that contains all items from the iterable in ascending order. So again, remember that word count is a iterable, just like that. So again, when we do for key in this, we're sorting all of the different keys in alphabetical order. So then all we have to do is we do fp.write, and the format we're going to put it in is we're going to do quote, bracket, colon, brackets, quote. We'll make sure to put a backslash in there to get a new line. We'll do dot format, and we'll do key, comma, word count of the key we have currently. So what this is doing for us is we're going through, get rid of that for now. What we're doing is we're going through and saying, what for each of the keys in our word count, this again is going to give us a list of the keys, an iterable list of the keys, and sort is going to sort that for us, and then we can do fp.write just like that. Okay? So if we go ahead and run this, but again, make sure since we're not using with, we do fp.close. Just like that. Now if we go ahead and run this, we'll do text.txt, and you'll see nothing came out because everything is now over here in sorted word count. And you can see we have a, am, and, as, been, and all of this is organized and sorted correctly from A down to W. All right, so this is what we can do now. And this is again showing how we can use a dictionary. We're getting a file, we're input validating our file, just make sure we actually don't crash the program. Open the file, we're doing reading it, so this reads all the text into a single string, uppercase all that text, and split it on the white space. So now we have a list of words that are all uppercased. Come down here, we're going to go ahead and use this regular expression right here. Again, it's important for you to understand regular expressions, but that's not something we're going to teach, so you should dabble in it on your own. But again, this is going to find \w is going to find all the special characters, \s is finding the white space, and we're substituting all special characters in white space, excluding underscores, with nothing. So that takes them all out of the strings. Then we're going to go ahead and check to see if it's already in the actual list. If it is, we're going to increment, not the list, if we're going to check it if it's in the dictionary already. If it is, we're going to increment the value associated with that key by 1. If it's not in the dictionary, we're going to go ahead and just add it to the dictionary, the key value pair. After that, we're going to open up a new file. We're going to use the sorted keyword here, the sorted function, to go ahead and sort this new list, which is the actual word count keys. And then from there, we're going to use each of those keys in order, followed by the actual value associated with each of them, which gives us a nice output file of all the different actual statistics of this file. All right. So now that you understand this, and now you understand how you can actually go through counting the words, what I want you guys to try now is I want you to alter the program you have. So instead of counting the words, what I want you to do is I want your program to tell you which line those words appear on. So for example, you'll have the exact same approach, but if the word robot is found on line 7, 18, 94, 138, the dictionary would contain an element in which the key is associated with a list containing 7, 18, 9, 94, and 138. And again, just like before, once it's done, go ahead and now put the actual output. So example, if you have some kind of text like this, we're now looking for the word we right here, appears in line 1. A appears in lines 1 right here, 2 here, and 4 right here. As appears on these, and so on. So you're finding all the different line numbers that these words appear on. So what I want you guys to do is I want you guys to go ahead and try this on your own. Take the code you already have from the previous example and try it on your own. See how far you get, pause the video, come back, unpause it once you're done, and we'll go over it together. All right, so did you give it a chance on your own? Or did you get a try on your own? Okay, so let's go over it together. So what we're going to do is we're going to go ahead and make a new file again. We're going to call this one 9-10b. And we're going to take the exact same code we had from the first one here, take all that code, we're going to put it in 9-10b, because these two pieces of code are doing very, very similar things. So now in this case, though, we're not going to have a word count anymore. We're going to have word lines, right? We're going to have lines where those words exist. We're going to open up that, but instead of going through and getting all the different words, we need to operate slightly differently. So in this case, we're now going to go ahead and we're going to read each line of the file. And in here, we're going to do line num, because we need to figure out which line number we're on. We're going to start at 1. We're going to say for line in fp.readlines. Then we're going to go in here, we're going to say words for that line equal line.upper, and we'll do dot split. Okay, and this right here is going to split the current line into words and uppercase each word. All right, after we've done this, so we don't need these anymore, and we'll close the file later, but we don't need these right now. We're going to then iterate through each of the words. So we're going to take all of this and we're just going to tab this in once. So now we have our words. We're going to iterate through each word. We're going to do for word in words. We're still going to remove the actual white space here, but instead of saying what we have down here, we're going to say if clean word.strip in, again, we change the list name to word lines. So we'll switch this right here. And we'll switch it right here. Then we'll switch it right here in those 3 spots. So now if it's like that, then we want to do something. And if it's not like that, we want to do something. So if it's not in the list or in the dictionary, we want to add a list now instead of just a number that includes the line num. And if it is in the actual dictionary, we want to append to the value we get back the line num we find or we're currently on. That's the only change that we really have to do. So instead of incrementing by 1, we're going to append the line number to the existing value list. And if it's not there, we're going to add a dictionary with a value list containing the current line num. Okay? Go ahead and enter this down because it's a pretty long comment right there. Just like that. All right, so now the only thing we're missing now is we need to make sure we also increment the line number. So we're going to come down here, and outside of the words, we're going to do line num plus equals 1. And that should give us what we want. It's a very small change, a very subtle change. Now we're going to go ahead and print these out. Okay, we'll change this up here in a second. Make sure again that we do fp.close here because we're now done with the actual file we were using originally. So right here, we're done with that file. So what we're going to do is we're actually going to take this fp.close and we'll actually put it right below in line with this for loop. So we'll close, we'll say close the input file. Okay. So now if we come down here, we do print word lines and we run this. Do that. We do text.txt. You'll now see we have the word I'm and then lines it came on. So we have 1, 6, 9, and 14. So if we go back in here and look at the actual text.txt, we have I'm here on 1. We have another I'm on 6. We have another I'm on 9. And we have another I'm on 14. Okay? So you can see, we can actually see which words are used more often. The word I is used a whole bunch on line 1. So we have I, it's right here, and right here. So we're going through that. Now we can also change that in the future if we wanted to only include it on each line number once. Again, does it matter too much? No, not really. It also shows a frequency. So what we can do now is after we've done this, we can come down here and instead of outputting it like this, where we currently, what we have is we have our sorted word counts. We should actually probably change that to sorted word lists or lines. So we'll run that real quick. Say text.txt. And our sorted word lines look like this. We wanted them looking like this. However, we wanted them to look like this with no commas in the middle. Okay? So how will we go about that? So at this point, we're going to look back into actual list printing. What we can do instead is we can use a join. So we can use a space. We'll do .join. And then in here, we'll put the words, just like that. And if we run this now, do text.txt, we see that we have an issue right there. It says expected int or string, instant, and int is found. So why did that happen? So the issue with this is, if you notice, join here actually is asking for any number of strings. When we come up here and add line number, we're actually adding ints. So what we need to do is we need to cast both of these to strings, just like that. And that should solve the issue. So let's check this again. We'll do text.txt, and it solves that issue. So we come over here, and now we have what we want. So again, that's an important idea right there about being able to actually highlight over the functions and see what they're actually giving you back, so that you can actually solve these issues on your own time as well. All right, so now that we actually have what we want over here, the actual output's correct, we can now move on. Okay, so now that we understand dictionaries, we're going to move on to what's called sets. Now, sets are very similar to dictionaries, and they're just almost the same, where they have mutable objects, and they're stored as an unordered collection of data. So just like a dictionary, they store data. It's a different way of organizing data, except for, unlike a dictionary, all items must be unique, and they can be of different data types. So what that means is a set is explicitly like, say, you imagine like a set of user IDs. Each user ID should be unique. So a set would be a good use for that. Names, you can have duplicate names. Two people can have the same name John, two people can have the same name Trent, two people can have the same name Susie. They can have the same name, okay? A set is not a good idea for that. However, a set is very good for unique IDs like social security numbers, user IDs, and so on. Okay, so a set is also in Python is created specifically by just calling the set keywords. For a non-empty set, you can call set with the arguments. And the arguments can be either a list, string, or tuple. Now, if you use a string arguments, the characters become set elements. So again, it breaks the string apart into its iterable sequence. Now, if you want a set of strings, you have to pass them as a list of strings to the set argument. Now, duplicates in the arguments are removed and only one is added. So that means if you add A within the arguments, it'll only bring back a set with the letter A in it once. Okay, so if you want to add elements to a set, you can do my set, whatever your set name is, .add, and we'll add the value. Okay, if you do .update, it'll add a group of elements to a set. So if you do a list of values like that, you can do .update and it'll add them all to your set. And then you can also get the length of a set by using the length function. Now, an important thing to note is if you do .add or .update and it already exists, it does not add it, it just ignores it because it already exists in the set. All right, so similarly before, you can also, again, it's mutable, so you can remove and discard methods. You can remove and discard things. So if you do .remove and that value does not exist in the set, it will raise a key error. If you do .discard, it does not raise an exception. It just tries to get rid of it. If it exists, if it doesn't exist, it says, okay, well, it doesn't exist already, it doesn't matter. So why would you care about using one or the other? .discard does not give you any kind of notification as to whether or not it was there to begin with. .remove does. If there's an error, .remove says, hey, that wasn't there to begin with, so I didn't have anything to remove. So you may have reasons in each of the different cases to use .remove or .discard, but in either case, just understand the difference between the two. Lastly, just like with the dictionaries, you can also do .clear to remove all elements of the set, just like how before we were able to move all elements of the dictionary. All right, so here's an example. A good example is like a raffle ticket example. So you can create a set of your tickets, and if you do .add 1, 2, 3, 4, it's going to add that single ticket to the set. If you do .update, you can update it with a list of ints here, and it adds multiple tickets to the set. And then if you want to discard a ticket, you can delete a single ticket from the set. And then from there, you can print the total tickets you have, and then you can print all the tickets by doing just the actual tickets set. Now, when you print a set, it's going to print out with the curly braces. That does not mean it's a dictionary. Okay, a set is a set, a dictionary is a dictionary. Make sure you understand the difference between the two. Okay. So just like with the dictionary again, you can use the for item in to iterate over a set. You can use if in and if not in to also check to see if something's in it or not in it as well. Okay, here's another example. You can go through and get the winners. You say winning is equal to enter winning ticket. If winning is in the ticket, the number you entered, then that is the winner of that actual raffle. If that's not in there, it just goes back through again and asks you for another ticket. Okay. Now, the important and the power of sets is when it comes to its abilities to work with other sets. Specifically, you can find a union of two sets. What this means is this set contains all the elements that are from both sets. So if I have a set 1 and a set 2, let's say set 1 contains A, B, and C, and set 2 contains C, D, E. If I get the union of the two, I'll have A, B, C, D, E. Okay, notice how there's no two C's. Both of them had a C. That does not mean you get two C's back. You get one C back because, again, a set only can have unique values. So here again is another example. If I do boy names and girl names, if I have Jim, Ben, Paul, Stephen, Jordan, and I have Jane, Jill, Rita, Sue, and Jordan, notice how Jordan's in both. Well, if Jordan's in both, it only comes out in the output once because, again, a set can only have one, but a union will put the two sets together. So intersection is the same thing, but opposite, okay? It shows you what it shows you a set that contains only elements found in both sets. So what that means is in this previous case, it will only show you the name Jordan. So here we have Jim, Jill, Ben, Paul, and Sue, Rob, Jim, Jane, Jill. What names are in both? Jim and Jill are in both lists. So the intersections is only where those two sets overlap. We can also have the differences of sets. So it contains elements that appear in the first but not in the second. So in this case, the order of which one you use matters. So in the previous ones where you did set 1 dot union set 2 will be the same thing as set 2 dot union of set 1. But now, if you do it this way, you're going to end up with an issue if you do them in the opposite order because it's going to have different answers. So here we have Jim, Jill, Ben, Paul, and we have Sue, Rob, Jim, Jane, Jill. If I say pie difference ice cream, we're saying which ones are in set 1 but not in set 2. Jim is in both, Jill is in both, Ben is not in the second one but it's in the first one, and Paul is in the first one but not in the second one. So what that means, those last two, Ben and Paul, we don't care about Sue or Rob or Jane, okay? Because they're only in the second one. We only care about what's in the first one that's not in the second one, okay? If I wanted to, you can flip it. Then if I flipped it, and if I said ice cream dot difference pie, then the output would be Sue, Rob, and Jane, because those three were in ice cream but not in pie. That's if I flipped it. Okay. So then there's also a symmetric difference. That's the one that says the set that contains the elements that are not shared by the two sets. So that's the same thing as difference, but it's difference on both sides. Okay. So if I have ice cream now I get both. So now when I go it's the same as doing pie dot difference ice cream and doing ice cream dot difference pie. So if I did pie dot difference ice cream, it would give me Ben and Paul, which you see down here in the output right here, Ben and Paul. And then if I did ice cream dot difference pie, you would see Sue, Robin, and Jane, which you see down here again as well, and they're all together. So it's basically the difference between the two sets, but again, which part are different on both ends. Okay? Another powerful advantage of sets is that you can use subsets and supersets. So you can check to see if one's a subset of another by saying is set A dot is subset of set B, which means is set A, all the elements in set A, also in set B. Okay? The same thing with superset. You can say is set A superset of set B. So what this means is set A big enough that all the entries of set B are also in set A? Okay, and that's going to return true or false. So again, here, if we have 1, 2, 3, 4, 5, 6, that's set A, and set B is 1, 2, 3. If you had the question, is set A a subset of set B? No, because set A also includes 4, 5, and 6, which are not in set B. However, is set A a superset of set B? Yes, because set B only has 1, 2, and 3, and all of those entries are found in set A, making set A superset of set B. This also means that set B is a subset of set A. Okay. All right. So if you guys understand that, I know that was a little bit of information. So let's see if you guys actually fully understand it. What makes a set different from a list? If I ask you that question, you should be able to answer a set does not allow you to have duplicate elements. If I asked you the question, are the elements of a set ordered or unordered, you should be able to answer that they are unordered. Again, the order of these do not matter, they just care about uniqueness. If you asked you how can you determine whether a specific element exists in a set, you should be able to answer that you can make a set of elements and see if it's a subset of a larger set. So you can say, hey, if I came back to, let's say, here, if I wanted to see if the number 3 was in the set A, I could say set B is a set of just the number 3. Then I could say, hey, is set B a subset of set A? And if it is, that means the number 3 is in set A. Okay, that's how you can check to determine if a specific element exists. After the following statement executes, what will be stored in my set? If I say my set is equal to set of Jupiter, what happens? If you said it was just a list with the word Jupiter, you're wrong. It's actually each of the letters because, again, when you bring a string in, only a string, it'll look at it as a character sequence. Because remember, strings are character sequences. All right. After the following code executes down here, what will be stored in set 3? If I say set 1 is 1, 2, 3, 4, and set 2 is 3, 4, 5, 6, and I want the intersection of the two, what is set 3 going to have? Remember, intersection is where they overlap. So set 3 will have 3 and 4. Okay? All right, so let's try this one together. Let's go ahead and write a program that opens a specified text file and then displays a list of all the unique words found in the file. So a little hint here, of course, we're talking about sets, so we should store each word as an element of a set. So let's go over here. We'll open up 9.4. Okay. And what we're going to do is we're going to go ahead and make this variable here. So we're not going to use a specific text file. We're going to ask the user to actually enter it for us. So the first thing we're going to want to do, though, is we're going to create a unique word set. So we're going to say unique words equals set, and I'm just going to do an empty set like that. And then we're going to get the text file to read from the user. Okay, then here we'll say file equals input. We'll say enter the name of the text file that you want to process. Okay, so again, just like before, we'll have our file validation here. We'll do try. We'll have our accept here. Again, if the file is not possible to be reached, we'll do try accept. And then down here, we'll go ahead and do print error file not found, quitting. Like that. All right, if we do find the file, remember to actually put return down here too. If we do find the file, we're going to go ahead and come up here and we'll say, we'll open the file. We'll do fp equals open. We'll put the file name that they gave us in here with read. And then we're going to read all text from the file, uppercase it, and split on white space. Similar to what we did before, we're going to do words equals fp.read, get all the text in one long string, uppercase all the letters in that, and then dot split it as well. Okay. Then we can go ahead and close the file because we have all the information we need from it. We do fp.close. Then now that we have all these words, we need to iterate over them. So we're going to do a make a list of all words after, remember, cleaning special characters from them. Okay, so we'll say clean words is a list. And we'll say for word in words, clean words dot append. Now this is a shortened way we can actually do this. There's actually a shorter way we can do this, but I'll show you the first way right now. And what we're going to do is we're going to do RE, so we need our regular expressions again, showing how powerful those actually are. Dot sub, because we're going to clean, we're substituting, R quote, bracket, same as before, caret, \w, \s for special characters and white space. We'll replace it with nothing because we want to just clear them out, and we'll do word. Okay, we're going to go ahead and append it. There's a shorter way to do it as well. I'll let you guys look that up on your own, but you can make it you can do all of this in a single line here. Okay, so after we have our clean words, we're going to go ahead and add clean words to set, and we're going to do unique words dot update because we have our list, and we're going to do clean words, which is our list. Okay, that's all we have to do to add that to the set. So we know that there's going to be duplicate words in that, but the set is going to take care of that for us and actually filter them so only the unique words are in there. All right, so now if we come down here, we can do print, we'll say unique words. Now I can go ahead and do for word in unique words. We'll iterate through the set and we'll print word. All right, so if we run this now, we'll do text.txt. You'll see we have all the different words. We have was, as, to, wouldn't, and all of these are singular. There's no duplicates in this at all. Okay. If we run this again with the World Series example, we have all these words here as well now too. We have a couple of years, that's considered those words, but we have all the different team parts of the team names there. Again, no duplicates. Okay. So with this being said, we've gone through, we made a set. We came over here, we opened up a file, made sure it worked, used a regular expression to clean all the actual special characters and punctuation from it. And then after that, we came down here, added them to the set with the update command, and we went ahead and printed them out here. Okay? So with that being said, what I want you guys to do is I want you guys to write a program that reads the content of 2 text files. Specifically, I want you to use the text.txt and the world series.txt that we've been using. And it should display a list of all the unique words contained in both files. So that's all the unique words. So that's every single word that's unique in both files. It should also then display a list of words that appear in both files. So that one specifically is going to be both files being the, let me explain that. So you have all the unique words, that's all the words in it. Then you have all words that appear in both files. Then you have the words that appear in the first but not the second, then the words that appear in the second but not the first, and you have words that appear in either the first or the second but not both. Now the second one, to explain it, the first one is going to be like a union. The second one is meant to be a intersection. So it appears in both. So does that make sense? I mean, the first one is supposed to be a union. The second one is an intersection. All right, so go ahead and take this and take some time on this on your own. Try it out. Use the example we just did as an example of how to do this. Try it. Unpause the video when you're ready, and we'll go over it. All right, did you give this a try on your own? So let's go ahead and go over this. So what we're going to need to do is we're going to basically take what we did before. We're going to take this code again, copy it, because it's going to be the exact same style of code. And we're going to go over to 9.6, and we're going to go ahead and paste it in. Now, we're going to be working with two sets at the same time. So what we're going to have to do is we're going to have to do file 1 unique words and file 2 unique words. Okay, so we have the words for file 1 and the words for file 2. Okay, so we create a unique word set for each file. Okay, then we're going to take this and we're going to double this up as well. So we're going to have file 1 and file 2, just like that. And we're going to enter the name of the first text file that you want to process and enter the name of the second text file that we want to process. Okay, so we have our file validation. So now we actually have to open up two files. We have to open up file 1, that'll be FP1. We're going to have file 2, which is FP2, just like that. We're going to say open both text files. Then after that, we're going to have words1 is fp1.read.upper.split. And then we'll have words2, which is fp2.read.upper.split. So we're reading all the text from both files, uppercasing it, and splitting on white space. And then we'll close both files. So we'll fp1.close and fp2.close. Just like that. All right, so now we have to clean the words on both. So what we're going to do is we're going to do clean words of 1 is equal to 4 words in words 1, or 4 word in words 1. Words 1. And then we have clean words 1 that append the word just like that. All right, so I told you before that there was a shorter way to write this, so I'll go ahead and show you how to do it with clean words 2. And I'll do clean words 2 equals a list, so use the brackets, of re.sub with the R quote bracket, caret for any occurrence, \w, \s. That's our regular expression. We're going to replace that with nothing, and we're going to do it with word. But here's the problem. At this point, it doesn't know what word is. So out of that, we're going to put the actual for loop down here. So we're going to do for word in words 2. And yes, that works in Python. So we're saying take this regular expression, and for each of the words, we're going to put that word, this variable right here matches this variable here. And we're making a list out of these items here. Okay? You do not have to do it this way. You can copy this exact code right here, 25 through 27, to do the same thing with clean words 2. But this is just a shorter way to do it. Okay? All right, so then after that, we're going to have to add to the clean words to the set. So we're going to do file 1 unique words dot update with clean words 1. Clean words 1. Then we'll do file 2 unique words dot update clean words 2. Okay, so now we have our two sets. So now down here, we're not just going to be printing them out. What we're going to want to do is we're going to print all unique words found. And we'll go ahead and print. Now remember, if we want all of them, we want the union of them, right? So we want to do print file 1 unique words dot union of file 2 unique words. I have an extra E there, but I guess it's been fine because it's going along with it. I'll go ahead and replace that. Do file 2 unique words. We just had an extra E there. We're just going to go ahead and fix that real quick. There we go. Okay. So we have our file, 2 unique words. That's going to give us all unique words. So if I run that, the first one will be text.txt. The second will be world series.txt. And all the unique words, you have times, pirates, the, city, as, Indian, Dodger, red, old, keep going. You'll eventually see some of the ones in here as well, from like Henry VIII, married right there, everyone, Anaheim. These are all the different words in the 2 files. Okay? So if we copy this, go ahead and paste this a few times, but we're changing them out. So the all unique words that appear that found, and I would say all unique words that appear in both files. Okay, and that's going to be the intersection. Okay. Then we have to say all unique words found in first file, but not in second file. That's going to be the difference. And then we're going to take this, copy that. I'm going to put that same thing here because it's going to be in the second file, but not in the first. And how are we going to do that? We're going to just switch them around. So we'll say file2 dot difference of file1. That'll solve that for this there. And we need one more, because this is going to be all unique words found in both, or that all unique words that appear in only one file, but not both. And that's going to be the symmetric difference. Okay. All right. So if we run that now, we have our text.txt, we have our world series.txt, and now we have our union, our intersection, we have our first difference, second difference, and then that from there. So can anybody explain to me why the intersection is different? I mean, it's empty. So the intersection is empty because these files do not share any words. So if you look right here, the first one, this is eighth, her, widow, so and so on. These are all just the words for that actual Henry VIII. The second line, the second difference is just the words of the. It's just the words of the second file, and then the symmetric difference is the exact same length as the union because each file is so different that each of the words only appears in each of the files once, like each separate file. So the symmetric difference in this case is the same as the union because there is no overlap at all. Okay. So with that being said, you guys understand now the different ways that you can use sets and their different properties like union, intersection, difference, and symmetric difference. Again, it's very useful to understand because when you need to work with different sets of data and see how they interact with each other, sets are very useful for that. All right. So moving on from there, what I'd like to do now is I'd like to talk about how we can actually serialize objects. So serializing an object is very critical when working with large data sets. When you serialize an object, it converts the object, so that's your list, your dictionary, your set, it converts it to a stream of bytes that can be easily and efficiently stored in a file. So Python is not the best with data and memory. It does not use memory very efficiently. However, when you serialize an object, it stores it efficiently. So when you do it, when you serialize an object in Python, it's called pickling it because the library is called pickle. You import the pickle module, and when you open it, you can open the file with the WB flag, which is write binary, or write bytes, write binary, whichever one you want to call it. And you can then do pickle.dump to that file, and it will store the object directly in terms of bytes into that file. Then you could do file.close to close the file. Now note, you can pickle multiple objects to one file before closing it, and you just have to make sure you remember that when you deserialize them or unserialize them, you go in the same order again. So here's an example. We have a person. This again is a set or a dictionary, excuse me, this is a dictionary with the name Paul, the age 55, and height 6'1". And then when you open person.dat, you can write binary and dump that person to the file and close the file. Okay. Now, when you unpickle something, you retrieve a pickled object. Okay. When you unpickle something, you import it, you open it with the RB flag or read binary or read bytes. And that right there is going to allow you to read the actual binary or data file that the pickle module creates. Then you can do pickle.load the file, and it will give you back the actual objects that you were working with. And you can also unpickle multiple objects from one file before closing it, just like you can pickle multiple objects to one file before closing it. All right, so here you go. We have our person.dat, you .load, that's our person, and then you can print the person name, age, and height, and that dictionary is all there, still ready to go for you. Okay, so what I want to do is we'll go ahead and try this. So let's go open up our 9-4 example, and we're going to write a program that opens a specified text file, then displays a list of all the unique words found in the file. A hint here is we store each word as an element of a set. We're going to also write a function that serializes this and write another function that deserializes it. So we already have this first part from 9-4. We just need to write these extra functions. So if we go back over here to 9-4, we'll go ahead and select all this again. This is our set example. I'll go to 9-4b here. Okay, so we have our code still. This is all the exact same. And what we're going to do now is we're going to add a couple functions. Okay, we can do functions, but actually, you know what? Let's just do in this case. No, yeah, you know what? That's a better idea. Let's go ahead and do functions. So we're going to make a couple functions. We're going to do def pickle it. We're going to add in our unique words. And in here, we're going to do fp equals open. And we're going to have our unique word pickles.dat, like that. And we're going to go ahead and make sure when we're pickling it, we're going to write binary. Then we're going to do pickle.dump. And we're going to use unique words that we brought in to that file. Then we can do fp.close, and then we're done. That's all we have to do for pickling it. Then to unpickle it, we'll do unpickle it. We'll do the pickle file, just like that. And then we'll do fp equals open. And we'll say the unique, or we'll actually do the pickle file this time, because we're being passed that. Pickle file, like that. We'll do comma, read binary, like that. Should actually put a colon there instead of a semicolon. All right, then we can do unique words equals pickle.load fp. It's going to be loading from that file pointer. We do fp.close, and then we can return our unique words. So if we want to use these down here before we actually print them, we can go ahead and pickle and unpickle it. So what we can do is we can come down here and we can say pickle unique words. We'll do pickle it, and then we'll do unique words. And then what we can do is we can unpickle unique words. And then that's going to be the new unique words, just so we can see it actually work. We'll do unpickle it, and we'll do the unique words pickle.dat, just like that. All right, then instead of going from new unique words, we're going to go from new unique words, just like this. And just to really show it, we'll go ahead and delete the actual old pickle right here, so we don't have it. And if I run this code now, we'll do text.txt, and you'll see we created this pickle.dat file, and we were able to pull back from that file that we just created, and we have all the different characters still, and all the different actual words from that file, the unique ones, just like before. Okay, so if it was that easy to actually pickle it, what I want you guys to try is do that same thing, but on the World Series winners. Now you're going to have to write a function that serializes this dictionary and deserializes, just like we did before, but you're going to do pickling it on both the, if I come back over here, you're going to be doing it both on the win count and years dictionaries. I want you to do two separate pickles on each of these. Okay, so go ahead and pause the video, try that on your own, and once you come back, we'll go ahead and go over that together. All right, you give that a shot on your own? So let's go ahead and go over this together. So the first thing we're going to do is we're going to open up 9-7b right here. We're going to copy all of this in just like we did before. Okay, like that. Now what we're going to do is we're going to take those same functions we did from 9-4b, the pickle it and unpickle it. We're going to edit those. So we're going to go over 9-7b. We're going to make sure we import pickle. We'll paste these down here. And when we do pickle it now, we're not going to just do unique words. We're going to do a dictionary because we don't know exactly which dictionary it's going to be. And we have a file name. So we're going to open up that file name. We're going to pickle the dictionary we're given, and we're going to close it. That's all we have to do for that one. Then when we unpickle it, we're going to get given a file name. We're going to open it. We're going to load it to whatever dict that is, the dictionary, and we're going to return that dictionary. So this is two very ambiguous functions that'll work really well for what we're going to do. All right, so now that we have that, we're going to come down to right before we get the user input, just to show that we can actually do it. We're going to come here and we're going to pickle the win count. We'll do picklet. We'll do win count, comma. We'll do win count dot dat. And then we're going to also go ahead and pickle the year winners as well. So we'll do picklet, do years, comma, year winners dot dat. Then we're going to go ahead and unpickle them. So we're going to come down here, we'll do unpickle win count. So we'll say new win count equals, we'll say unpickle it, we'll say win count dot dat, and then we'll unpickle the year winners as well. We'll do new years equals unpickle it year winners dot dat. Okay. Now remember, it's not enough just to do that. We also want to make sure we can actually see what it looks like. So we're going to come down here, and where we see win count, we're going to change that to new win count. And then we say new years, we're going to change that from years here, 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 and here. So in those 4 spots. So now we're using the unpickled lists, or the unpickled dictionaries, excuse me. And now that with that being said, we can actually see if it works. So we'll go ahead and run this again. We'll say, let's say 1940, and it did work. So we say we had the Cincinnati Reds, and the Cincinnati Reds have won 5 times. Okay, so again, pickling is very easy, but it's a very useful tool for actually working with large data sets. By doing that, you now are able to work with these large data sets. You're able to work with dictionaries. You're able to work with sets. And as a challenge for you guys, what I'd like you guys to do is I want you to try this one on your own. So what I want you to do is I want you guys to write a program. This is separate from pickling, but this is a culmination of what you learned about dictionaries and sets. I want you to write a program that simulates a simplified version of the blackjack card game between 2 players. The cards have the following values. You'll have numeric cards that are assigned a printed value on them. You'll have jacks, queens, and kings, a value of 10, and aces that are valued between 1 or 11. So it's either 1 or 11, depending on the player's choice. Now, the way this program should work is you should have a dictionary that holds all of your different cards. The program should deal 2 cards from this dictionary. So when you deal a card, you remove it from the dictionary. And following this, it should check to see if one player lost already by going over 21. They shouldn't have, but it would just check it instead. If not, the program should ask the first user if they want another card or if they want to stop. So it's the same exact things, just like with blackjack. You ask them, do you want another card? Do you want another card? And you keep going, and you keep going. All right. So after they finish, the next person adds more cards as well until they stop, or until they go up to 22 or 21 or higher than 21. And after that is done, what I want you to do is I want you to compare the two. If both players went over 21, they both bust. So therefore, it's a tie. If they have the exact same value, it's a tie. And then if one's higher than the other, but then the other one, but they're both below 21 or below, then the one that has the higher value wins. Okay. So go ahead and give that a shot. Again, this will also work and repeat. So like if after the first game's done, they should ask the user if they want to go again. So pause this video, try this on your own. You're going to be using dictionaries in this. But try this on your own. If you understand dictionaries, you should be able to get through this one. It's going to be difficult, but go ahead and give it a shot. Unpause it when you're ready to look at the actual answer. All right, were you able to give this one a try on your own? So I know this one's difficult, but this one is a very big culmination of what you've learned. So let's go over this together. So we'll go ahead and open up 9-9 here. And what we're going to do is we need to first start by building a deck. Okay? So we're going to do def, and we're going to have a function called reset deck. This function will give us a deck here. That's a dictionary like that. And it's going to return the deck. Now, the way we want to actually organize this deck is we want to be able to say something like ace of spades. And that's going to be a :1, just like that. And then we want to have something like 2 of spades, and this will take a long time to write. So we'll do 2 of spades, 2, and so on. What I'm going to do is I'm going to copy this, what I already have in. I'm going to copy this from here. I'll put this directly in here. This will have all the different cards we need. So what I want you to do is pause the video real quick. Make sure you have this in your code, and then once you're done, go ahead and unpause the video and keep following along. Okay. So once we have this actually in our code, what we're going to do is we're going to make another function. Okay, before we even get to the main, we're going to make another function. And we're going to call this def, so def, deal cards. Okay, so remember when we're having a deck, we need to be able to deal cards. We have deck, and we have number. So it's the number of cards we want to deal and the deck we're currently working with. So we're going to say if the number of cards they want to deal is greater than the length of the deck, so how many cards we have left, then we just want to set number equal to the length of the deck. So we'll give them whatever cards left over. This right here is if the user wants to draw too many cards, only draw what is left. Okay? After that, what we want to do is we want to say pull cards from the deck and add them to the running sum. That sum is going to be our hand value. Like that. And we'll say for count in range of number. So how many cards we're actually grabbing. Then we're going to say card equals random dot choice of list of our deck dot keys. Okay, so what this is doing is we got to make sure we import random too real quick. Okay, so what this is doing is it's saying give me a random choice from this list, and this list, we're converting the deck keys, which is all of the dictionary names of the different cards, to a list and choosing one at random. All right, then we can say value equals deck dot pop card. The reason we're popping this card from the deck is because, again, we do not want to draw the same card twice after it's already been drawn from the deck. We can go ahead and print the card name. And then what we can do is we can say if ace in card. So if we did pick up an ace, the value is not just that simple. We'll say response equals input. Would you like the ace to count for 1 or for 11? Do that. Like that. Then we can say if response equals 11, then we'll do hand value plus equals 11, else hand value plus equals 1. Now, if it's not an ace, come down here to this else, if it's not an ace, we do hand value plus equals the value that was given from the card. Those values are these numbers that follow the cards. Okay, so then after we have that actually done, we're going to go ahead and return the hand value back to the user. So this right here is going to return running some hand value to, or say just that, but it's going to return it back to the user. Okay, So with that being said, we now have a deck of cards we can work with right here, and we have a function that allows us to deal cards from the deck. All right, so if we come down here to our main, what we can do is we can go ahead and start. And the first thing we're going to do is, because we know we want to be able to keep going, if we keep playing until they want to stop, we're going to go ahead and just put keep playing until the user wants to stop. And we'll have while true. We'll just keep this in a loop. Each play, we want to reset the deck for this hand. So we're going to shuffle the deck. So we'll do that by saying deck equals reset deck. That'll put every card, it'll make a brand new deck with all the cards in it. It makes a brand new dictionary. And we return that dictionary back. And now that's equal to this deck right here. All right, so then from there, we're going to deal 2 hands to both players. Okay, so we're going to say print. We're going to say player 1's hand. And we're going to say P1 hand value equals deal cards. We'll say the deck that we're currently working with, and we'll say 2 cards. We're going to do the same thing. Actually, let's make sure we actually print hand value first. We'll print player 1's hand value. That format. We'll say P1 hand value. And we'll make sure to put a new line character after that, so we can just format it nicely. We'll copy this, paste it there, and we'll do player 2's hand value. So we'll do P2 hand value, player 2's, and make sure you put a 2 there as well. So we have 1, 1, 1, 2, 2, 2, 1, and 1, or 1 and 2. All right, so after that, we need to then move on to dealing more cards to each. So we'll start with player 1. So we'll deal more cards to player 1. So we'll say cont equals true, because we got to keep going until they want to stop. While cont response equals input, player 1, would you like another card? Yes or no? Now, because of the fact that we want to make sure we don't want to accidentally overdeal somebody, we'll say if response equals yes. So if they said any other key, it's not going to give them another card. We'll say new card value equals deal cards from the deck. We only want 1 card at a time. P1's hand value is going to then be plus equals the new card value. And then we'll print player 1's new hand value. That format is P1 hand value now. And then we'll put a \n here just for formatting, just like before. And then we can come down here and we can say if response is not equal to y, or P1's hand value at this point is greater than 21, we'll go ahead and say cont equals false, because they're done. Okay, so that's how we deal more cards to player 1. We'll go ahead and deal more cards to player 2 as well. We're doing the exact same approach. Make sure you shift tab it back, just like that. Change all the 1s to 2s. Player 1, player 2, player 2's hand, player 2, player 2 there, player 2 there. Okay, so make sure, again, double check everything, triple check everything. Make sure you got, if you do copy and paste, you have player 2 everywhere where player 1 was. I think I do, that's good. All right, so then after that, both players are done adding cards to their hand, and we need to compare the hands to find the winner. We can then say if P1 hand value is greater than 21 and P2 hand value is greater than 21, then they both bust. So that's a tie. Or the other time there's a tie, you have P1 hand value is equal to P2 hand value. In both instances, we print you tied. Okay? Elif P1 hand value is greater than 21, we print P or player 2 wins. So if player 1 busts, we say player 2 wins. Elif, if player 2's hand is greater than 21, then we say print player 1 wins. So this would be a problem, but we check to see, are both of them greater than? That's only true if both of them are greater than, then they tie. If one of them is greater than it, then the other one ties, just like that. Then we need to check to see, okay, well maybe if player 2's hand value is greater than player 1 hand's value, then we print player 2 wins, okay? And then lastly, we have P1 hand value is greater than P2 hand value. Then we say player 1 wins. Okay, the last thing we're going to do is we'll put else. In case something crazy does happen, we'll go ahead and print who won, question mark. And then because we're in this while true loop up here at the top, we'll go ahead and ask the user if they want to play again. So we'll say response equals input. Would you like to play again? Y/n. Now, in both cases, we should probably put dot lowers there and a dot lower here and here on all the responses, just to make sure that we're not causing any issues with that. So now we have all those right there. If they say yes, or if they say no, in this case, if they say no because they want to stop, we'll go ahead and break out of the program, out of the actual loop, and then we'll come back to here, in line with the loop, all the way down here. And we'll print, thank you for playing. Okay, so let's step through this one more time. So you're in the main, come up here, you're in a loop. You set your deck for this hand. You deal the hands for the player 1 and player 2 by calling the deal cards function. Again, the reset deck is going to give you a brand new dictionary every time of this exact code. Then the deal cards is going to go through and start popping cards off. So it's going to start taking cards out of the deck based on the key that you found. So you drew that card, you take it out of the deck. The value you're given is from pop. That pop also takes it out of the actual dictionary. Then after that, we check to see if they want the ace to be 1 or 11. After we have all that, we come down here, we deal them more cards, and we check the actual winning right there as well. So if we run this real quick, we see right here, players 1's hand's 15. They got a 10 of spades and a 5 of diamonds. Player 2's got a 6 of spades and 6 of clubs. So player 1, would you like to have another one? We'll say yes. So it's an ace of clubs. Because we'll bust otherwise, we'll say 1. So now we're at 16. We'll stop there. Player 2 would like another card because they're at 12. They're at 21. They get perfectly 21, so they say no, and player 2 wins. If we say yes again, we're dealt completely different hands. Player 1's now winning with 19. We'll say no because player 1 doesn't want any more cards. Player 2 says yes. They have a value of 18. They're still losing, so they have to say yes again. I have 28, so they lost, and it immediately says player 1 wins. All right, so this is how you can do that. And again, when you hit no, it says thank you for playing, and then you're done. All right, so this code right here shows you how you can actually work with a dictionary, send dictionaries back and forth through functions, pop things off of a dictionary right here, and actually use multiple dictionaries to build a game as well. All right, so in this chapter, we've actually covered dictionaries, including creating, inserting, retrieving, adding, deleting key value pairs. We've talked about for loops and the in and not in operators with dictionaries. We've covered dictionary methods. We've covered sets, including creating sets, adding elements to and removing elements from sets, finding set unions, intersections, and differences, and symmetric differences, finding subsets and supersets, as well as how to serialize objects, which is very useful for large data sets and large data variables. All right. Hopefully all this makes sense. If it doesn't, please go back, rewatch the video, ask questions. I highly encourage it. And until next time, I will see you later.